Oh, I got rid of the thing. Oh, there it is. Oh, that's cool. So we're going to use some graphing calculators and do some stuff here. But it says use a graphing calculator. So does everybody have a calculator? If not, grab one real quick. Use a graphing calculator to graph these cubic functions, and they give us 3 different cubic functions. And then we're supposed to use the graph of each function to answer the questions. Okay? So I think the best way to do your notes on this is we're going to do one function at a time. So we're going to fill out this column. So things that you need to write down, function. In the first column, you need to write down how many distinct factors does f of x have. And we'll talk about that. We'll talk about that in a second. The next thing you need to write down is what are the graph's x-intercepts. That's important. I remember one year I was teaching, and I would get a function and I could graph it without the graphing calculator, and the students were calling me a wizard. But what I'm going to teach you is how I can graph a graph without a graphing calculator. I know what it's going to look like because I've memorized whether it's an even power or an odd power. I know where it's going to go in, I know where it's going to go out, and I know where it's going to cross the x-intercepts. And so I can kind of ballpark what the graph would look like. The next thing that we're going to list in that first column is the graph tangent to the x-axis or up here? So let me, to help you guys along, because one of the things is, what do you need to write down? You don't need to write down this paragraph, okay? You could read it, but what we're focusing on are these 3 functions which are written down right here, okay? And maybe I could do a better job of explaining that to you guys. That's just telling you we're going to graph those 3 functions. Okay. And when we graph them, I'll take a screenshot and we'll put them in the notes. But we'll do one at a time. Okay. So you don't need to write that down verbatim. You don't need to write that down word for word. Okay. I know that I could probably print this off and give it to you guys, but that's a lot of paper. That's a ton of paper. We'd have to kill a lot of trees. Huh? They did in the...
Paper is one tree.
Oh, let's focus on the math. That'll be a great project we could work on later. How many sheets of paper can you get out of one tree? But I'm willing to help you guys. Like, I don't want to, when we had that discussion about, like, keeping up and writing stuff down, I get that. So just raise your hand and ask me to move around or whatever, okay? All right, can we keep going?
Do we just write down the first?
Yeah, so now on this, I do want you to write down these words, okay? Because it makes a difference. All right, so you're going to make the first column, you're going to say function. All right, and then you're going to write down how many distinct factors does f of x have, and I'll define what that means in a second. Factors it means exactly mathematically what factors means. How many multiples, what are the things that we're multiplying to get the function? Okay. And then it says, what are the x-intercepts? Where does it cross the x-axis? I'm going to jot that down. You guys should know what an intercept is, but just in case you don't remember, it's where it crosses the x-axis. Okay. Is the graph tangent to x? Or does it cross x at each intercept? Tangent is a fancy word that means touch. So somewhere I got to write the word touch. Maybe towards the top here, just make a little note. Tangent. And if you took geometry and you used the tangent function, you're like, oh, I know what tangent is. Well, kinda. But tangent means touches. And that's an informal definition, but when something touches something, we call it the tangent. So if you sine and cosine and the tangent function, it just touches at one point, actually, is what I should say. Touches, and then in parentheses, say at one point. That means it doesn't intersect. Kind of just touches. And it says, how many turning points does it have? Okay. And then the next thing that we're wanting to know is how many global maximum values. And so when we say maximum values, probably you should put max is a hill. So when we graph curves, maxes are hills and minimums are valleys. And we'll talk about that when we see some graphs. So the graphs are going to change direction. When they do that, they'll create little hills and they'll create a valley. The maximum value, which could be global max or local max, depending on the graph, is a minimum or maximum value for y. A local minimum value is based on a domain definition. So as you'll see, we'll have little humps. That's what I always call them, little humps. And the humps could be a hill or they could be a valley. And so when we talk about a local maximum, we're talking about a maximum that is inside of the function. And we'll cover all this when we have the graph to look at. Okay? And then the minimum is a valley. So, as you guys are writing this down, when I go to graph a function, the function will come in through the bottom, go out the top, right? Well, this little hill, that's a maximum value. But as it curves back around, this would be the valley. That would be the minimum value. So as we do these cubic functions and polynomials, polynomials can have little humps and valleys depending on the degree that they are. And there'll be a pattern that emerges just like the pattern that emerged that you guys figured out after we just graphed a bunch of functions. We're like, hey, if it's an even power, this happens. If it's an odd power, this happens. If it has a leading coefficient of -1, it flips it. And so we're going to do that again today. Okay? Do you guys have this written down? No? Okay, I'll give you a couple seconds to get it written down. So, yeah, I think that while you probably feel like you're going to get carpal tunnel, it really does help you guys to write this down. It really does, because you have to process the words, you have to think about them, you have to read them, you have to write them down. And I don't mind slowing down and waiting for you guys.
What's carpal tunnel?
Carpal tunnel is when you use your hands too much. I actually had it. Maybe it's because I wrote too many notes down in my life. But there's a thing called the carpal tunnel. You have a ligament that goes around your hand like this. And if you use your hands a lot, that ligament kind of clinches down and cuts off some nerves that go through what's called the carpal tunnel. Carpal tunnel is not the actual word of the disease, I suppose. But anyways, they go in and they cut the ligament. So if you look real close, I got like a little scar. So during COVID, I had to post a bunch of stuff online and type a bunch of stuff online so that kids can continue to learn. And then I developed carpal tunnel. But now I'm fine. See? Huh? Yeah, it is better than arthritis for sure. But so anyways, let's graph f of x equals x cubed. So pull out your handy dandy calculator and go to y equals, clear out everything, and just type in x raised to the third power. Go to zoom and just select standard. That's fine. And so I'm going to move my face out of the way. Let's take a screenshot of that. And let's just look at this. I'm just going to post it somewhere over here to the side so that we have room. And you should probably sketch it as best you can. So just kind of over here to the side. And then maybe just kind of label the function. So just kind of sketch it as best you can and then say f of x equals x cubed. Okay. So now for this first column, we're going to fill out all this information for this graph. I think I need to zoom out just a little bit. Let me go to this. Yeah. So when they say factors, what they mean are, what are the distinct factors? So what this really is this is really x times x times x. Which one is unique or distinct? Well, we only have one, it's x. Okay? So even though we have x times x times x, there isn't a distinct factor, right? So there's just one distinct factor. Now when they say distinct factors, let me show you what I mean by that. 24 can be divided into 2 times 12, and then 2 can be split up into 2 times 3 times 4, and then that 4 could be split up into 2. So 24 is equal to 2 to the third power times 3. That's what we call the prime factorization of 24. What are the distinct factors? Well, probably just 2 and 3. Does that make sense? So this would, for a number, the distinct factors would be 2 and 3. What do we multiply to get the number? I mean, we're multiplying 2 3 times, but we're only counting that as 2 distinct factors. Does that make sense? Except over here we have x's where we're doing it. So it says, what are the graph's x-intercepts? Well, where does that look like it's crossing the x-axis? It crosses at 0. Okay? And we'll unpack that in a little bit. Is the graph tangent to the x-axis or does it cross? Crosses at x equals 0. So it crosses the x-axis. Remember, this is the x-axis and this is the y-axis. Okay? It says, how many turning points does it have? 0. It doesn't have any humps or valleys. And because it doesn't, and so when I say, well, they call it turning points, but let's just write down the word humps. Okay? So then, because it doesn't have any humps, it has no max values, and it has no minimum values. Okay?
So what's the first block again?
How many distinct factors? Yep.
Like under that,
I get
like the little bar.
this little line thing. You want me to zoom in?
No. Just go to the second box, the F of
The
X
F of X
equals.
equals X3. What's the on that one?
What is that thing in the first box? Is that one?
This is a 1.
Oh.
There's one distinct factor. Okay? All right, are we ready to move on to the second graph? All right, so let's grab our handy dandy calculator. I'm going to clear out this graph, and now we're just going to plug in x times the quantity x minus 2. Now this will be a parabola in a sense because we're going to have x times x. So it'll be x to the second power, right? You guys know we're going to distribute the x through the parentheses. Actually, no, I take that back. It's supposed to be x squared. Good thing I caught that, huh? So let's do that. Let's put it in the right way. And then times x minus 2. So, my bad, that's going to be x cubed. Because you have an x squared times an x. Let's graph it. Now this looks a little different, doesn't it? Okay. This looks a little different. So let's take a screenshot of this. Move my face out of the way. All right, so now this one, I'm going to zoom in just a little bit so we can get that set up. Whoa, too much. So this is going to be f of x equals x squared times the quantity x minus 2. Now, if you were to expand that, that would just be x cubed minus 2x squared. Okay? Anyways, this is different. I have two distinct factors. This is, let me explain what I mean by that. This is a factor, so that's one factor, and then this is a factor. So we have two factors. What are the factors? X and x minus 2. Those are my two distinct factors. Okay? The second row says, what are the graph's x-intercepts? Where does it cross? Well, interestingly enough, well, I shouldn't say where does it cross. Where does it touch the x-axis? Well, it touches it at x equals 0 and x equals 2. That's no accident. Okay? Tangent crosses. Well, it's tangent when x equals 0. Remember I said tangent means it touches? If we look at the graph, it doesn't cross the x-axis. It just touches right there at x equals 0, doesn't it? It doesn't cross all the way through to the other side. It just touches there. But it crosses at x equals 2. Okay? It says how many turning points does it have? Now, turning points are humps or valleys, right? So this one doesn't necessarily look like it has a hump or a valley, but notice this one has one hill and one valley. So we would say it has two turning points. Okay? Now, the minimum value and maximum value for the whole graph, the global value, the global max is, the highest it can be is infinity. But it does have a local max, and that local max occurs right here. So it has one local max, okay? And just by coincidence, that happens and occurs at x equals 0. It has one local minimum, and you guys probably don't realize it, but it's about right here. So I don't know. That probably we could calculate it on the calculator. Let's see what it is on the calculator. It's not quite 1. It's right here. So we don't need you don't need to write this down, but I just want to. I can calculate the minimum. I'm just going to go to the minimum, and I'm going to go over here for a local min. I'm a little bit to the left of the valley. I'm going to move a little bit to the right of the valley. Whoops, not that far right. Then it's going to ask me to guess where I think the valley is at. And so I got 4/3. Basically, 4/3, 1 1/3. So what we'll do is we'll say x is approximately 4/3. Okay. And I'll give you guys a second to write all that down. Now, before we move on to the next one, is there anything there that you don't quite get or you have questions on?
I don't know if like the f of x equals x cubed one.
Yeah.
For the x-intercept part.
Yeah.
Why is it 0 since this graph also like touches 0, and f of x, the x squared, and then it's has to be x minus 2. Because in this one it touches it in like the same general place it does.
That's just a coincidence. But, so what is the y value for a point on the x-axis?
Like just right on that?
Yeah, in general, yeah. It'd be 0. So what we're really doing, and that's a great question, and I was going to get into it at the end, but we could do it now. To find these in both scenarios, and I want to make sure I leave enough room. So if I say 0, because f of x is the y value, right? So if I say f of x equals x squared times the quantity x minus 2, right? And I set that equal to 0. The reason they ask how many distinct factors we have, the only thing that guarantees that this equals 0 is if x squared equals 0 and x minus 2 equals 0, because then you would have 0 times 0 equals 0. If I take the square root of both sides, I get x equals 0. If I add 2 to both sides, I get x equals 2. So that's why this touches the y value is equal to 0 when x equals 0, or y is equal to 0 when x equals 2. And the same thing works out for this one. This one we would just say 0 equals x cubed. Take the cube root of both sides, you would get x equals 0 times x equals 0. Does that make sense? Because 0 times 0 times 0 equals 0. So that's why y equals 0 when x equals 0. So where it touches the x-axis depends on the factors. How many times it touches the x-axis depends on the distinct factors. So for example, let's graph this next one and you'll see. Well, let's not graph it. How many distinct factors do I have for this next one? And we'll graph it at the end and see if we're right. So for this one, I have an x, and I have x minus 2 and x plus 2. Now I'm going to have an x times an x times an x, so this is a cubic. It's a third degree polynomial, but I'm going to have 3 distinct factors. Now I know that if I set each factor equal to 0, if I say x equals 0, that's it. And if I say, actually, let me make some room. This is how you can find this, and we'll graph it. If I set each one of the factors equal to 0, I'm going to get x equals 0. If I add 2 to both sides on this one, I get x equals 2. I'll just write that over here. And then over here, if I say x plus 2 equals 0, then we would say x equals negative 2. So my zeros are going to be x equals negative 2, x equals 0, and x equals positive 2. Okay? Are you guys with me so far? And then, guess what? It's going to cross. Are any of those repeats? No. In other words, I don't have x squared. I don't have x minus 2 squared. Right? Well, it's going to cross at x equals 0 and x equals negative 2 and x equals positive 2. How many turning points is it going to have? Well, it's always going to have one less turning point than the power. So since this is x to the third power, it should have 2 turning points. And if it has 2 turning points, it's going to have one local max, because it's a cubic. It goes in from the bottom and comes out the top, and one local min, because it's a cubic. It's going to have 2 humps. Why does it have 2 humps? Because it's x to the third power. Okay? Guess what we're going to do? I'm going to graph it. But let me leave this up here because I went kind of fast. So let me give you guys a chance to write that down and kind of process it. Writing it down is the first step. Processing it might take a little bit of time. Let me zoom out so you guys can see it a little better. Oops, that's not out. So what I'm saying is it has 1, 2, 3 factors. I can set each one of those factors equal to 0 to find the x-intercepts, because the x-intercept occurs when f of x or y equals 0. Well, in order for y to equal 0, each one of the factors has to equal 0. So by setting each factor equal to 0 and solving, that tells me what value of x we're going to have these x-intercepts at. It being a tangent intercept depends on the power of the factor. If you notice on this one, the tangent occurs when x equals 0. Well, that's this one, and notice that this is x squared. So if you have what we call, that's what we call a multiplicity of 2. You can have x equals 0 as a solution and x equals 0 as a solution. So when you have a multiplicity of 2, or an even multiplicity, it's going to be tangent. It's going to touch the x-axis. If you have an odd multiplicity, it's going to cross the x-axis. Okay, and I know that's a lot to soak in. But anyways, so because all of these factors are raised to a power of 1, in other words, this is x to the first power, this is x minus 2 to the first power, this is x plus 2 to the first power, they're all going to cross because the multiplicity is an odd number, which is 1. Where is it going to cross? At 0, negative 2, and 2. How many humps is it going to have? It's going to look very similar to this one. They call them turning points because it's going up, then it turns around, then it goes down, then it goes up. Those turning points are always going to be 1 less than the power. Well, it has the potential to be 1 less. If you look at the parent function, it doesn't have any turning points, so to speak. It's always increasing. Okay? Turning points are like where it's increasing, then it's decreasing, then it's increasing. That gets a little more exaggerated as we start to manipulate the function. Okay? Let's graph it and see. Are you guys ready to graph it? Okay, let's graph it and see what we're working with here. So go in here, clear this out, and I'm going to say x times the quantity x minus 2 times the quantity x plus 2. Hit graph, bam with the bacon sizzle. Crosses at -2, crosses at 0, crosses at +2. Has 2 humps, has 1 maximum and 1 minimum. We'll take a screenshot of that. And I'm going to zoom in on that so I could write what it is, and then I'll zoom back out. So this one here is f of x equals x times the quantity x minus 2 times the quantity x plus 2. That's it. That's all there is to it. Okay? Any questions on that one? All right. So let me zoom out so you can finish writing it down. How do you guys feel about that? Because that's a lot to kind of digest in one setting.